Hi all. For this video, we're going to jump into our first video on summary statistics. So how do I take a list of quantitative data, of numeric data, and summarize it based on some characteristics? And we're going to focus on three. We've already talked about one, which is measures of location, meaning where do I sit in a data set relative to everybody else in the data set? And we saw we can use percentiles, quartiles, or z-scores to do that. For the next few lessons, we're going to talk about measures of center. So this lesson is going to answer the question, how do I figure out where the middle of the data is? And there are a couple of ways to measure the middle. And the very popular one, the most common, the one you've probably heard of before, is called the mean. And this other math classes, this is usually what we're talking about, or more specifically, an arithmetic average. And arithmetic in math class usually means we're adding. Not mean. We're going to add up all the data values. And then we're going to take that sum and we're going to divide it by the total number of values. And I don't know about you, but I, as a statistician, am lazy. I don't want to have to write that word phrase over and over again. So we're going to see symbols for this formula. And we know that we can have parameters for population data, or we can have statistics when we have sample data. And we calculate them both the same way, regardless of whether it's population or sample data. We add up the data, divide by how many data values there were, but the symbols will change. So for population data, we're going to use the Greek letter mu to represent the mean. For sample data, we're going to use the symbol x bar. And you'll notice a pattern throughout this statistics course. Generally, when we're talking about population parameters, we're almost always using Greek letters. And when we're talking about sample statistics, we're almost always using English letters. And that pattern is going to follow us throughout this first unit as we learn new quantities. Both of these equations have the same structure. I'm doing a division problem. I'm dividing a sum of values, adding up all the values. So I'm going to use the shorthand for sum, which looks kind of like a wonky E. This letter here is a capital sigma, and it means to add or to sum. I'm going to divide that sum by the number of data values in the data set. And since this is a population, that's capital N. Similar idea for our sample statistic, except now I have my sum of data values divided by my sample size. Same math. Symbols tell me whether I'm looking at parameter or statistic. We're going to do a quick example, and then we'll talk a little bit about a list of numbers. So I have the data set 1, 1, 1, 1, 2, 3, 5, 5, 6, 10. And I want to calculate my mean. I'm going to assume, unless I'm told otherwise, that I'm looking at sample data. We know that is easier to collect, and that's what statistics is all about. The X bar by adding up all my values. Plus 1, plus 2, plus 3, plus 5, plus 5, plus 6, plus 10. And I'm going to take that sum and divide it by the number of values in the data set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to do this in my head because I'm lazy. So that's 16, 21, 26, 29, 31, 32, 33, 34, 35. So 35 over 10, which is 3.5. And one thing you'll notice about that answer is that my min is 1, my max is 10. 3.5 is closer to 1 than it is to 10. So why is this a measure of the middle? What the mean is actually looking at is if I were to take a number line that goes from 1 to 10, and I were to treat this like a seesaw, and I were to put people at each of those points in my data set, so 1, 2, 3, 4 guys sitting at 1, I've got a data value at 2, a data value at 3, 2 guys sitting at 5, a guy at 6, and a guy at 10. And I want to put the little pivot underneath my seesaw, and I want it to be perfectly balanced. What that mean is telling me is where should I put that pivot? And it's saying if I want this beam to be perfectly balanced, I should put my pivot for this seesaw at 3.5. If I put the pivot for the seesaw there, the left and right sides will stay balanced and it will not tilt in either direction. You'll notice more data over here, a little less over here. I have lots of data points at 1 that are fairly close to that mean. On the other side, fewer values that are close, 1 that's way far out. And this 1 guy is counteracting these 4 guys here. So means don't just look at the values in the list, they look at where they sit on our seesaw, and then the mean is going to be the balance point for that set of data on a seesaw. We can find our mean the same way we found our 5-number summary, which is running 1var_stats on our list of data. So I can plug this into list 1 and run 1var_stats. That would be the very first thing my calculator spits out. All right, so that's all for the mean. If you have questions on how to calculate it or what it's measuring, feel free to send me an email. Otherwise, I will see you in our next video.